Recording in progress. So very good afternoon to everyone here in Malaysia. Very good morning to Dr. Rayenda in UK. And I think it's still very early in the morning, about 8, I think, in the morning or 7 in the morning. All right, so today we're going to have this session with him of this dedicated global classroom. And not to forget that I think Dr. Jerome is also inside the room here, right? Jerome, are you here?
Yes, Dr. Ivan.
Yeah, okay. Thank you. Thank you for being here also. Right, so I think it's just meet up for friends that have not seen each other for quite a while, Dr. Ray. And right, so for just before we start this particular session, I think we have about so far signing in here about 264. I would just stop this sharing first, right? And thank you for being here this particular afternoon. We're grateful. Some of the participants actually from outside UNIMAS, pretty sure. And of course, this will be, I hope, the sharing going to be a good platform for this our global classroom, especially dedicated for the course Econometrics and the sharing by Dr. Rayenda, which on the topic of machine learning research on dedicated research on business economics and finance related types of research. Right, so I think you have anything to say, Dr. Jerome, before we start the session?
Yeah, all right. It's really nice to see you again, Dr. Ray. So I hope that all the students here will have, can learn something from these sessions today, because Dr. Ray is also very well-known academician as a researcher. So I hope that everyone will have a good time, learn something from these sharing sessions. Right, back to you, Dr. Evan.
Okay. Right. Thank you. Thank you, Dr. Jerome. So I think we're going to, I just pass this flow. Before I pass the floor, let me just introduce a bit of Dr. Rayenda. As I know, he graduated from a PhD from University of Science Malaysia here in Malaysia, and then he was with us here in UNIMAS, FEB, Faculty of Economics and Business, for quite a while, and then after that he was in Bahrain, right, and for a bit short time there, and then now joining University of Coventry or Coventry University in the UK. So and he, of course, most of his publication specialization mostly on finance related topics. And of course, is one of the research powerhouse also, and published in numbers of top journals in the field itself. Right, so I will now pass the floor to you, Dr. Rayenda Krishna Brahmana, if I pronounce correctly. Right, so this session you can have, and then after that we can have a question and answer. I can have about maybe perhaps 45 minutes up to about that kind of lecture, and then after that you open up the question for anyone who want to ask a question. Right, so I'll pass the floor to you. I think you can share your screen.
Okay, thank you, Dr. Ivan. So let me share the slide first. So yeah, first of all, thank you, UNIMAS, for having me again. For those maybe we never met, but I taught in UNIMAS from 2014 after I graduated my PhD until the lockdown. The lockdown ended in 2021, June. So like what Dr. Ivan say, I've been very long. I spent my life actually in Malaysia, half of my life, like 13 years, 14 years, something like that. And now I'm back. Nice to meet Dr. Jerome also. Actually, both of them was my in charge. I have to report to them, while Dr. Jerome was the deputy dean and Dr. Ivan was the deputy dean or the editor-in-chief in IJBS. So I'm fair. presentations, and when I saw your attendance, and then I realized that okay, this is one of things that I miss out also, and all those students saying, "Oh, can I have the manual attendance and so on?" Anyway, so let's start the talk. I choose one topic about machine learning and economics and business research with some reasons actually. And my talk will not be very long, I think around 30 minutes. And then we're going to have another hand-in slide 15 minutes, and then maybe the rest it will be like Q&A. I prefer Q&A actually. And why I choose this topic, there are several reasons. So during the lockdown, and then most of us having our group in the WhatsApp, and then the WhatsApp thing, and then we are very active in the WhatsApp, and then I asked my alumni group in the WhatsApp, what are their company needed, especially for economy and business. Most of them say that they are looking for data science. And then when I asked them, okay, why now this data science? And then it related to the big data and so on and so forth. And of course, digital economy, which I'm going to let you know later on. And then one of the tools in the data science, a kind of data analytics, because quite different data science and data analytics, is machine learning. And it differentiates from the discussion that I have with my friends in UK, in Luxembourg, or in Indonesia, or even in Thailand. They have one common things that to differentiate one student to another student is how they know about the data science, only the basic one, only the advanced things. And one of it is machine learning. And I thought at the beginning it's very difficult. This is one of the reasons that I do not want to go. This is one of the reasons that at that time I didn't want to pursue this field, until I realized actually this is not that difficult. And then I will show you later on why. So if you, I think most of you know English, if you're from economics, especially he won the Nobel Prize, and he keeps saying that the basic things in data science actually econometrics. So when Dr. Iwan asked me, Ray, can you give one talk about econometrics? And I think, oh, why not we talk about these data science things? So my journey, I'll tell you first my journey. So during the lockdown, when many people go participating in stock market, and then again, we have another group. And in that group, we realized so many apps, investment apps does not have many investment analysis. And that time, we start to learn Python. And then I think 2021, before I resigned, I think from Unimas, so maybe around March or February. And then we have, in the end, we have one project using Python for doing these apps called pytrader.id for Indonesian's market. And after that, we realized what else that we need to put in this website or in these apps. And one of it is actually machine learning. Actually, you can go to pytrader.id, you can see that it's working, but this is for Indonesian's market. So because most of applications, investment available now, they do not have one predictions model. So we are thinking that why not we add one kind of predictive model. And one of the way to give the predictive model, we call it as machine learning. Don't worry, I'm going to let you know also what is predictive model and so on. And then after that, when I arrived in Indonesia, after I resigned from Unimas, I watched one old video. At that time, this is very old video. I watched this video when I was in Unimas, but I think it's quite boring because it's very lengthy and it's quite technical. And in 2019, 2018, big data is not a hype, so I skipped this video. I just saw in the first 2 or 3 minutes and I skip it. So while I'm in Indonesia, because I'm waiting for my visa to go to Bahrain, and I watched this video, then I got some insight from this video. For example, let me share the sound for share sound. Okay.
Tens of thousands of data points. So what's high dimensional here? And that's important because I think if I were to just poll people and ask them about, oh, what do you know about machine learning? I think a lot of social scientists would know, probably the first thing they would say is lasso. Is probably the most likely answer. And with lasso, you'd be like, what am I going to lasso here? It's 142 variables. But is that really true? What is the variable? We're so used to running regressions, we say, oh, we have 142 variables, but that's not really right. I mean, there could be interactions of variables. There could be triple interactions. 142 to the k power can get very big, very fast. So really, this is one of the kind of mind-opening things that help me understand things. The default that we turn to, let me run a linear regression, I have 142 variables, interactions or this exotic thing that I might add, is the way we have of approaching the problem, the default way of approaching the problem. There's nothing odd, there's nothing special about linear regressions, and I'll come back to that later. So more generally, when you think about high dimensional, you shouldn't be thinking about number of, it's not a counting exercise on the right, it's all the ways in which we're allowed
So
to
yeah,
combine the variables.
so when I watch this video and then I start get confused. Why? Because my training during my PhD, we know that we learn, especially when you learn research method from, I don't know who teach research method in UNIMAS nowadays, previously actually me and Dr. Puah. So we learn the basic things about how to differentiate correlations and causations. And then when you join econometric class, we learn about, start to learn about regressions. And in the regressions, I still believe Dr. Jerome or Dr. Ivan, or maybe those who come from outside, when we learn econometrics, the first thing that your lecturer teach you is about the blue things, right? The blue. And at that, most of us in econometrics, we know blue is very important for estimations model. So when he started talking about machine learning, and then he said that, okay, machine learning can do forecasting or predictions. And I'm thinking, okay, that's what regressions can do also. So what make them different with regressions? How much is difference? In econometrics or research method, we learn how much difference about correlations and causations, but we never really learn the difference between causations or causality made with the predictions, or maybe we not learn about estimations versus predictions. And as a person trained in estimations thingy, so I at the beginning I do not get what this machine learning all about, because again, what I just told you in the econometrics, our what to tell you, how to say it, our first things that we learn in econometrics is about the blue estimations. So when you keep watching this video, and then Sendil Mulanaitan, his name is Sendil Mulanaitan, he keep telling that, okay, in these predictions, then you don't need the blue, and then how much is different with estimation, and so on and so forth. Then it gives me another questions. Or if machine learning is only for predictions, which is actually can be done with regression, so why we need to learn machine learning? And it means it gives me a signal that I have to go back to the basics of econometrics. And this is why I have to tell you that why your first 2 or 3 chapters in econometrics is really important. Is you look at it as quite easy, or you just memorize it. Okay, Dr. Ivan or Dr. Jerome teach us about assumptions and econometrics. You have 10 blah 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 blah, residual have to be what the heterogeneity, homogeneity, so on and so forth. But actually it become really important later on when you want to become a data scientist. And after 3 or 6 months, then I realized that what Engris said, the economics Nobel laureate said, is totally correct. Those who does not understand econometrics, usually they cannot do data science. Why? Because people will always think that data science is always about computer science, which is not. And I will show you later on why. So this is remind me about more sophisticated tool for my research. If you watch the video later on, it shows how impactful, how powerful is machine learning. I have one research about narcissistic CEO, which is we want to know whether a narcissistic CEO usually will have earnings management or not. This is our simple research. And how to know whether the CEO narcissistic or not? One of the way is we measure it using the photograph. So if the if the CEO put many of his photo in the annual report, the more it is, the more high narcissistic he is. And this is very common in leadership or in in HR study or in psychology study. Or in fact that if you go to one organization, you watch so many pictures in that organization, it tells you that actually the leader in that organization is not give us problem, actually not give us problem, it give my co-author problems because my job in this paper is only estimations. My co-authors, both of them, Ashley and Maria, they have to open the annual report and then they have to check how many pictures of the CEO in the annual report and how big it is. And it takes time. Why it takes time? Because you just imagine that the year is 2009 to 2015, and then the sample of the company is 514. So just imagine that if the machine can do it for us, right? For example, I just simply give you one picture of me, and then the machine will learn and then can capture, okay, this is Rayenda Brahmana. And then based on that, prediction and based on that training, he can predict whether this Rayenda is narcissistic or not. And then even we can tell the machine to put that, oh, if the pictures tell you narcissistic, put 1, if not, put 0. In the current literature in accounting and finance especially, we cannot do this until the computer science find one kind of method, like they call as convolutions, which is we can train the machine to read our photo, and then based on that photo, they can tell this person is narcissistic or not, or maybe this based on the photo, this person is attractive or not, which is I'm doing one paper about it now. From one pictures, we can train the machine to tell that later on, if I put you another photo, you can tell this person is attractive or not. This is actually inspired by one paper from Dr. Ivan. I still remember he has one paper about handsome and beautiful lecturer or teacher, something like that. But that kind of research, if you read that Dr. Ivan paper, I think in social indicator research, if I'm not mistaken, it's almost similar with what I did or what we did in this narcissistic CEO, which is an obtrusive method. But if you have a machine learning, we can do it automatically as long as we teach the machine how to do it. So because of that, then I'm thinking that, okay, so means that we can do a lot of things using this machine learning. And it means that using this machine learning, we can do so many kind of research. For example, disclosure. If from accounting and finance and your supervisor or your current research is about disclosure, CSR disclosure, corruption, anti-corruption disclosure, whistleblower, or what else? Climate change mitigations disclosure, and so on and so forth. It will be problematic, or it will be time consuming for us because we need to take the disclosure manually or manually. But nowadays, using the machine learning, we can predict whether that annual report has this disclosure or not, or a good disclosure or not. One of the way, or maybe another research about the predictive model. This is for those who really love in time series, like Dr. Ivan. For example, we can predict whether for example, the gold price can predict not the gold price, the inflations can predict the gold price, or maybe we can predict whether if a country has give the higher tax, it will make the good economic growth. It's when I told you this, it's quite like estimations model, but you can make it as a predictive model. I'm going to tell you later on what is the difference. Or maybe another research about micro expressions. Micro expressions is what I told you earlier about the picture. We can show the picture, we train the machine, and the machine will tell us whether this person is attractive or not, narcissistic or not, and so on and so forth. Or the sentiments paper, for example, we want to know whether actually patients or the government, people really love Elon Musk or not, or many type of sentiments, and many other kind of research we can use from the machine learning. And based on this, my how to say, my exploration in this field, then I watch this video again, which is why I keep saying it. I keep saying I watch this video. I hope that after this meeting, this class, you can go to the YouTube and then watch the video. And there is one YouTube video from Marginal Economic Revolutions from Harvard, MIT. I'm sorry, from MIT. There are three prominent scholars, especially in economics, educational economics. Two of them are recently got the Nobel Prize, Guido Inbens and Josh Angris. Of course, the moderator is Isaiah Andrews. And then they are talking about the impact of machine learning on economics. So if you can see here, Guido and Angris and Inbens, even the Nobel Prize winner, which is very famous with the Econometrics, if you know Inbens, still editor in Econometrica, they are keep debating whether machine learning really powerful for economics or not. Why? Because in econometrics, we learn about heterogeneity, we learn about shock, we learn and many other things, and we believe that, Angris believe that it will not give additional things for those in economics. So the good things of this three video, which is one from Sendil Malanaitan, and the other one is from the Margin Revolutions from MIT, Inbens, Angris, and Andrews, is easy to understand, and I hope that you can watch it after this class. And after watching that, then I get insight what is machine learning, how it be useful in economics and business, and what are the advantages and disadvantages, especially the good things that I can tell you that when I watch Inbens and Angris is how they explain it is very easy, especially for undergraduate student. So let's start what is machine learning all about. In econometrics or in research method, we have learned about the difference between correlation and causality, right? In my class, usually I give you the example is whenever the leaf from the tree falls and the stock market falls. So let's say one person make an observations, and the observations show you that whenever the leaf from the tree falls and the stock market fall, does it means that the falling leaf cause the stock market falls, right? Which is actually not. And from this, I hope you still remember your basic things in econometrics, that from this kind of illustrations, we learn that correlation is not same with the causality. And then it's quite different when we learn about, okay, the gold price decrease and the stock market decrease. Does it mean also correlation? Will it show a causation? If it shows you causation, what kind of assumption that we need to fill in, right? Which is you learn in your first 2 to 3 chapters of your econometric class. So, and this is very easy to understand because we learn in a research method, we learn in the econometrics. And I give you another example. This is from the textbook usually we use in Unimas. From there about the ice cream and shark attack. When we plot pictures, you can see that there is, whenever ice cream sales increase, the shark attack also increase. And then does it mean that when we sell more ice cream, then it will have more shark attack? Which is not, right? Then this is the most important, the basic thing that we need to understand first before we go to the difference between estimations and predictions. Why? whenever we cannot differentiate what is correlation and causality, then it will be very hard for us to differentiate what is estimations, what is predictions. So please remember that correlation is not causation, and then after that you can understand the difference between causality and predictions. Causality, I think this is your third chapter or your first chapter, is A cause B if occurrence of A always lead to another specific B, right? This is causality. It is quite different, which is A predict B with certain probability. Can regressions become a predictions? Yes, if it meets certain certain conditions, which is, I think you will learn it in more advanced econometrics. But please make before we learn about the machine learning, please differentiate what is causality and predictions. So causality is A cause B, meanwhile prediction is A predict B with certain probabilities. And these certain probabilities in econometrics model, we can, where's annotations? All right, this one. The certain probabilities, actually we can, in econometrics model, we can see whether the model is fit or not. And then this comes again what Dr. Ivan and Dr. Jerome already teach you about model fitting. And from this model fitting also, I think Dr. Ivan already, or Dr. Jerome already teach you about RMSE, or the MSE, or the MAA, and so on. So these simple terms that we keep ignoring it when we learn econometrics, it will be very useful when you learn machine learning. And this is why I told you from the earlier, which I agree with Angris, that data science basic is econometrics. Let me clear the drawing. Okay. Okay. Wait, how to, okay. So in other words, whereas causality is deterministic, prediction is probability. So why does it importance? It is very important later on because machine learning is not the God tools, which is that, okay, it's a hype words, then we have to use machine learning. That's totally wrong. I always tell this to my student. If you want to choose a tools, it's back again to your research objective. And then you have to understand the procedure, because the procedure in regression or in estimations model is quite different with the predictive model. For example, in regressions model, we really emphasize on our diagnostic test, isn't it? For example, we want to make sure there's no heterogeneity, there's no autocorrelations, there is no serial correlations or autocorrelations, there is no what else? Autocorrelation, heterogeneity, multicollinearity, or the normality, or we have to make sure all the 10 assumptions is fulfilled or not. So there is estimations. Predictions is more lenient towards that. If you watch the video from the Sandel-Moller-Knighton, and then you can see that, in fact, that most of predictive model in machine learning, they can ignore it, those blue estimations. Why? Because again, the estimations and predictions are two different things. And then the interpretations also quite different. When we learn regressions, let's say Dr. Ivan or Dr. Jerome teach you about, okay, the simple regressions model. And then we learn that the t-value higher than 198, and then you can say that there's a significant or statistically significant relationship between A and B, right? There is a relationship between A and B. For example, in economic terms, 1 unit increase of A will cause how many percent increase in B, right? That's the interpretations in regressions model. But in predictive models, especially made by machine learning, is quite different with what we learn in regressions. So it alerts me about the differences. For example, in machine learning, it more on how does the model predict sample. It more on the proof of property, more or less useless, and let the data reveal the structure. Means like this. In machine learning, actually it become a hype again because of the big data things, because of the digital economy 2015, 2016. And then inside one of the dimensions in the digital economy is big data. And when the big data comes and people start to looking at, okay, how to analyze this big data, and one of it is using the machine learning. In estimations model, if you learn about normality, sometimes I'm not teaching you about the p-hacking, but we learn about how to winsorizing the outliers, isn't it? We have to neglect some outliers, or sometimes we just ignore it. But in machine learning, we cannot do that. We cannot ignore any outlier, even though it's an outlier. We have to put all the data, we have to train it, even though there's an outlier. So this is what it means that it predicts out of sample. In estimations model in econometrics, we learn in the normality, for example, some econometricians will not agree with this due to the p-hacking thing and so on, but theoretically you have to winsorizing the outliers. But in predictive model, especially using the machine learning, we don't care about the outlier. You just can pump in all the data and then teach the machine learning to differentiate it and train them. So it proof of property more or less useless. So even though the outlier maybe is not useful later on, but you still can use it. Why? Because you need to teach the machine to know whether this is good data or bad data, and let the data reveal the truth, not our professional judgment due to, for example, your Jack Bera things. And in statistics, it's quite different. Statistic, as you learn that regression actually based on the mean value, which is underlying in the probability model, and it has to meet certain conditions, right? Especially in what you learn in econometrics. So because of this difference, it tells us that machine learning is quite lenient rather than than estimations. Why? Because the objectives are different. All right, the objectives are different. So what is actually machine learning? Machine learning is actually a combination between statistics, computer science, and econ and business for the FEB domain. We can use this machine learning. I'm going to show you now. But before that, I just want to tell you that in machine learning, you need the basic statistic, you need the basic computer science, you need the basic in economic business. I'm not saying the advanced part. Then actually you can learn about how to use the machine learning. The problem is that before 2019, most of us in economic and business, we are really good in statistics, but we are really rubbish in computer science, right? Because none of us ever learned about computer science, especially programming. Even, for example, we have to be honest, in econometrics, for example, let's say Dr. Ivan or Dr. Jerome teach you about stata or using EViews, that we don't have time. We don't have time to teach you how to write the syntax in stata or how to write the macros even in Excel. Why? Because we only have 14 meetings, and then there's no time to teach you about that, right? So most of the time, because due to the limitation of the classes, usually we are only teach you how to click this and click that, with the hope that, with the expectations that students are more outside of the class, which is most of us didn't do that. Don't do that, right? Most of us are not doing that. So the problem is when we want to learn machine learning, we don't know how to about the basic computer science until comes one new software which is really easy to understand, to learn, which is named Python. When Python comes out, I think most of you know the Python things. Let me put it here. And then even myself thinks that it quite troublesome for me to learn these things until I found out actually Python is very easy to understand. I think I already told Dr. Ivan, the rules learning basic Python is 20 hours, 20 to 40 hours, the basic things. So if you can spend your time 20 to 40 hours to learn the basic Python, then it's actually the basic things you need for your machine learning. Of course, after that, you need to update yourself until you can learn machine learning, because in Python, there are many things you can learn. So how to, okay. So, yeah. So actually, econometrics of machine learning is not a new thing. To be honest with you, it's not a new thing. The first paper in econometrics about machine learning is not 1998. I can find is 1970, but it's about more on economic growth, which is I don't like it because I'm from finance. That is Dr. Jerome and Dr. Even Phil. So I choose one paper 1988 from White. That economic growth paper is from Jeff Wooldridge. I think most of us know who's Jeff Wooldridge if you learn econometrics. So one paper in 1988 about economic predictions using neural network, the case of IBM daily stock return, right, 1988. And there's 1994 papers, neural network and statistical technique in marketing research from and Bates, 1994. And then there's another paper from Trippi and Desiano, 1992. My dissertations in during my master degree, I took my master degree in University of Birmingham. My dissertation, you can go to their library, actually, online library. My dissertation is about predicting the anomaly using ANN, which is artificial neural network under chaos theory. So master degree was in 2006 or 2007. So actually, this kind of econometrics and machine learning are not a new things. It's very old, but again, why it arise again is because of the big data enter our field in 2015, 2016. So the outcome of machine learning in econometrics is generally similar with the regressions. The difference the machine learning allow more predictive model of our machine learning. So when you already understand regressions, then we can use these regressions as our predictive model. I give you example. For instance, there's X and Y in machine learning. So in machine learning is totally, I'm not learning the same. It's similar what we learn in regressions. In regression, we have X and Y, isn't it? We have independent variable and we have dependent variable, endogenous and exogenous. In machine learning, you need to have X and Y also. The X in machine learning, they call it as features, which is in regressions, we call it as IV. But in regression, the Y, we call it as target. Meanwhile, in econometrics or in regression, we call it as DV. So, yeah, so it's quite the same. The difference is only the terms. Why is the terms? Because, let me show you again, in econometrics, we learn about linear regressions, logistic regression, and those extensions, for example, arch family, like guards, EGR guards, what else? GJR guards, and so on. We learn about FAR set, VCM set. In machine learning, this linear regression, logistic, and all those extensions extended become a predictive model under GLM, SVM. As you know, there's SVM guards. There's rich regression because of your heterogeneity. You have also you have the lasso, you have neural network, you have random forest. So machine learning in econometrics is actually the extension what you learn in Dr. Even and Dr. Jerome class. So my point is, whenever you don't understand econometrics, it will be very hard for you to use machine learning later on. Again, machine learning is rose again due to the hype of digital economics because of the big data and predictive model become intriguing again. And there's new data source available, API from the Twitter, but now Twitter, due to this Elon Musk, previously is free. Now Elon Musk asks us to pay if you want to use the API of Twitter for those who want to use the sentiment research. And then we have Google Trend for those who want to see, for example, the sentiment. You can go to the Google Trends or you can go to the Google. For example, you want to see that whether the mobile download the data, and then you can make regressions against the economic growth, for example, or you can learn about the sentiment API from Facebook and so on. So the new data source available nowadays, not like my time or Dr. Jerome time or Dr. Even time, where the data is very limited, but due to this data, then we can do many things in predictive model. And the technology make it approachable and doable for non-computer science. And this is the rise of the death of Python. Was not many of people looking at it at the beginning because it's too easy. But due to this machine learning things, due to the big data, now everyone can learn Python. You just remember I told you, you just give your time 20 to 40 hours learning about the Python, then you can actually master the basic Python. And in fact, that the website that I showed you earlier, the python.id, is actually due to we learn around 20 to 40 hours Python. You can imagine with that time, we can make one website about stock market analysis. And to me, Sandel Malanaitan talk rang the bell. So in a predictive model, it's more on the model fit. Again, for those who still remember what Dr. Jerome and Dr. Ivan teach them, predictive fit. Therefore, the MSE and RMSE become very important. Okay. Wait, why I can't go next? Okay. And then in machine learning, we need to do data splitting. In regressions model, in estimations, usually what we teach you in econometrics, you have to collect the data, and then sometimes you have to clean it, and then you regress it, isn't it? But in predictive model, especially in machine learning, is quite different. You take all the data, you train it. After you train the data, you validate it and you test it. And the training data set is used to train the machine learning. The validation is used to tune the model hyperparameters, and the test is used to evaluate the performance of the model, because you want to know whether our machine learning, our predictive model is already good or not. And then after we do the data splitting, then we choose the model. For example, are you using the reinforcement neural network? You want to use deep learning, on and so forth. But as you can see here, the basic thing in machine learning is quite different with what you learn in regressions. In regressions, you just collect the data, clean the data, regress it. But in machine learning, you have to train it, you have to validate it, and you have to test it. The good news for you is this three process is automated. Totally automated. I'm going to show it to you. It's maybe what I'm telling you now is quite okay. What is this Rayenda talk about? It's quite blurred and make me confused. You will see later on, because I'm going to show you after this what it means by train, validate, and test. And then we choose the model. And then after we choose the model, we train the model. Why? Because again, it's about model fit. We want to see the MSE, RMSE, or MAE. And then we evaluate the model. Why? Because we learn in econometrics, the more it close to zero, the more robust the model, isn't it? For example, if your MSE score is 0.0001, it tells the model is really good compared to the MSE is 100 something or 10 or 1, right? So we have to evaluate the model, then we make the predictive model. So what is actually, you just imagine that you have a logit model. Logit model is logistic regression. I think you learn this in the econometrics later on. In logistic model, we learn the dependent variable is binary. The IV, let's say, continuous. Let's say the research problem is the effect of corporate governance on financial distress. And our research question is, does corporate governance affect financial distress? One example. So in regressions model, in estimations model, what we're going to learn and what we're going to do is, we have decided, okay, the main IV is corporate governance index. The DV is financial distress. If panel data, we regress it under panel regression regime. Whether you want to use fixed effect, GMM, TSLS, whatever it is, you regress it. And then after that, you get the coefficient, isn't it? And the coefficients from the corporate governance index, the beta 1, for example, is the magnitude of relationship. Or alternatively, we can use distress versus non-distress for the DV, which is a binary variable. For example, if company is distress is 1, if not distress is 0. So if there's a significant relationship, I hope you still remember how to interpret the result. To interpret the result is the probability of distressed company with high corporate governance is lower than the company with low corporate governance, right? That's how we interpret in estimations model, because we found it's significant and positive in the logit model. But there's a second probability that we're going to use machine learning. It's the same thing. The main IV is CGI, the Corporate Governance Index. Our diff is still the same, financial distress. And we want to know whether Corporate Governance Index can predict the distressed company or not. So you can see the difference here, can predict the distressed company or not. So machine learning can be utilized. How we utilize it, we can train the machine first. How we train the machine, we have to tell them that every time a company has CGI score lower than example 5, it means low CGI. Higher than 5 is high CGI. And then whenever the CGI increase, the distress decrease lower. We keep training them doing this. Okay, we make predictions. Whenever the new data comes in, that one is the trained data. It's quite different. You're going to see later on. We already trained with one certain data, and then we use another data, we enter it. When the new data comes in, then the machine learning will say that, okay, what else? For example, DG company have financial distress. Every time we enter a new data, the machine will tell us directly about whether the company is distressed or not. This is like your Y-hat predicted model in regressions, right? So we can train the machine first, we can predict it, and then we can evaluate it. So every time there's a CGI score, we are going to know whether the company will distress or not automatically. In regressions model, we only have the efficiency beta 1. In machine learning, we already have the output. They will give us 1 or 0, distress or not, based on the CGI score. So how much is difference? In predictive model, most of the time we are very lenient. Sandel, Moore, and Knighton keep saying we can ignore, but for me, I just say it will be very lenient in the blue concept in estimations. And we don't have this kind of endogeneity problem in predictive model. Of course, in regression, we have endogeneity problem, but not in machine learning. And in many cases, good predictions, but bad for estimation. For example, our model in predictive model using machine learning is really good. The MSE is 0.001, but when we run it as a regression, the R-square negative, or the R-square is 0.00, or maybe it violates the blue. In many cases, it means that you cannot compare the result of estimation from regressions and the predictive model. And this has become the huge debate in econometrics, whether how good is good for predictive model, because most of the cases, good predictive means sometimes it's bad estimations. This is the process that we're going to do now. All right, please remember the most important part in machine learning, especially in predictive model, we are looking for the good MSE and RMSE. I'll give you an example before to run it. This is one of my working paper, still under review. I do not know. They keep not rejecting. It's already third RNR. Anyway, I'm using the cryptocurrency volatility prediction with different model. In econometrics, I'm not sure whether you already learned the GARDS family or not. We can use GARDS to estimate our volatility, right? And then in machine learning, we have SVM or SVR. We have neural network. We have deep learning. So my research in this paper is I'm just comparing which model has a good predictive model. And as you for 6 cryptocurrency, 3 is the big cryptocurrency and 3 is the stable coin. As you can see here, the GARDS model, look at the RMSE score is very bad, right? Compared to another predictive model, compared to SVR, neural network, or deep learning. Why? This is far from 0. This is far from 0. And look at what happened to the SVR GARDS, which is almost 0, or even the deep learning for the stable coin, you can see is almost 0. And then we can make conclusions that for example, deep learning is a good predictive model for volatility. Or in this case, we can say that economic shock is a good predictive model for cryptocurrency volatility. Well, for one of the example. And then let me go further with any other research. So how to apply this is yeah, I can skip this one. And anyway, how to apply this is the one that I already told you. We can use many type of data, attractiveness with the picture, sentiment from the Twitter, turn at top, mobility, immigration, traffic, cultural norm or work culture, and the new way to analyze the data. So this is the good thing of machine learning. So example new kind of data for tone of influencer. You just imagine that when you want to do your FYP, for example, you want to know the role whether the words of Elon Musk can predict the Dogecoin price. The Dogecoin, and I think you know what's Dogecoin, right? So our hypothesis is whether Elon Musk words can predict the Dogecoin. So how to do this? You have to go to the Twitter API, take any words from whose his name Elon Musk, and then we can make a sentiment analysis based on Elon Musk's words, and then we predict whether every time Elon Musk say something or tell something about Dogecoin, the Dogecoin will increase. So we can make a predictive model of it. So later on, the practical implication, the practical contribution is, we know that every time Elon Musk tells something about the Dogecoin, we need to buy Dogecoin. Why? Because our predictive model show it will increase the Dogecoin price. Or the micro expression of borrowers. This is one of my friends in, I think Dr. Iwan, if he still remember, we invite him in our DBA class. He and his bank actually making one model based on micro expression. So based on the photo of the application, the applicant, sorry, the credit applicant, then they can know whether the applicant is trustworthy or high integrity. So this is another kind of new data in machine learning. Another example, this is from Wang et al. 2023. Again, it's using the artificial neural network. The accuracy is low, right? 60%, which is 0.6. This is about stock price crashes in China. So they want to know about the predictive model for the stock prices crash. And Petal et al. 2020 about price prediction scheme for financial institutions using 4 different models, LSTM, and then they have their own neural network model, so deep learning model, and then they want to compare it. And as you can see here, this is back again, the most important part when we do the machine learning. We are looking at the RMSE, MSE, MAE, and the MAPA. So again, if you already forget what is MSE, RMSE, MAE, MAPA, you have to go back to your econometrics and learn it. So this is the 4 important things before we go to the predictive model in machine learning now. Again, I just want to remind you, please remember, there are 4 important terms from your econometric class, which is MAE, which is mean absolute error, MAPE, mean absolute percentage error, MSE, which is mean square error, and RMSE, which is root mean square error. So yeah, I know this is quite boring. So this is why I told Dr. Iwan, let's do it the machine learning things. So let me stop share this one first. I think I gave Dr. Iwan the video, which is about the Google collapse. So this is another things that I just want to tell you guys that, how to say this. One of the reasons that I pending to learn about machine learning is Python is because it gives me a problem to install the Python, the Python software, the Python Studio. And most of us, including me, giving up because we failed to install the Python Studio. Until my friend told me that why you waste your time to install that Anaconda or Jupyter or FSC, and other kind of Python studio. Actually, Google provide you one studio that you can learn Python very easy, no need to install, which is they call it as Google Colab. So if you, yeah, you can follow me if you want. I just want to show it to you. So if you have your browser, your internet browser now, you can go to the Google Colab, right? And then you can find this welcome to collaboratory Google. So you can click this. And then of course you need to sign in with your Gmail account or with your any type of other account. You have to register it, and then it's actually if you already have your Gmail, no need to register, but in case you don't have your Gmail, then you need to register. So it will appear like this, the Google Colab. And what is the advantage of Google Colab? One, no need to install anything, all right? Two, it's easy, it's a friendly user. And then every time if I'm doing workshop about Python, I will not tell them, okay, install Jupyter, install Mu editor, install what else? Install Anaconda. No, I will tell them, okay, go to the Google Colab first. What is the disadvantage of Google Colab? There are many, actually. One, if you are making one programming for web applications, Google Colab cannot do that. Or I test about this one AI generated image software called Kandinsky. The Google Colab failed to do that, at least in my Google Colab. But my friend said they can do it in his Google Colab, but in my Google Colab failed. But I have to use it in my Jupyter. So you can go to the Google Colab, and usually when you go to the Google Colab, you can click the new notebook. After you register. After you register, you go to the new notebook, and then it will appear like this. The problem with Google Colab is one of the disadvantages. You can see this connect button here, connect. You have to click connect first, so it connect to the internet. Otherwise, you cannot use this Google Colab. And then you can start do the coding here. So for those who want to learn machine learning using Python, if you are the beginner, my suggestion is you have to use the Google Colab first. No need to make yourself in trouble installing Jupyter, Anaconda, or other studio. So this is the Google Colab, and then you can make your coding here. So let me show you what I sent also in with Dr. Iwan. I already give it to Dr. Iwan. So if you have the data that you get from Dr. Iwan, you can go File, Open Notebook, and then click the file that I gave to you. You open Notebook, and then click the file that I gave to Dr. If you manage to download it. So you go to there, and then you click it. Okay. So again, you go File, Open Notebook, and then click the file that I sent to you. All right, so yeah, you have to browse it. This is a lot because you can upload here. Go to the upload. In case you don't have, if you're confused, right? Go to File, Open, go to Upload, choose File, and then you choose file, the file that I already sent earlier. Okay. So let me give you 30 seconds for that. So you just need to upload it. When you upload it, it will appear like this. And this is one of machine learning predictive model using LSTM. Okay, the basic things. This is not a workshop, but I just want to show you how fun is machine learning. If you see this, pip install yfinance. Why? Because we want to ask the machine, we want to ask the machine to install Yahoo Finance library. So yfinance is a library provided by Yahoo Finance because you want to take the data from Yahoo Finance. So this is the code with pip install means please install Yahoo Finance Library. So this is the coding. After that, I just click, excuse me, I just click run the cell, this one. Just click the run cell, and then it will appear like this. Yeah, of course, I already installed it. Okay, I'm sorry. And then after that, you need, usually in machine learning or in predictive model, we need to import other library. The basic things are, this is another thing that I have to tell you. You remember that I told you that you need to learn 20 to 40 hours, right? Don't jump to learn predictive model. If you jump to predictive model, you're doing the same mistake like I did. So my suggestion is those 20 to 40 hours, you spend your time to learn pandas, which is panel data, pandas, one of library in Python. You can go to YouTube, for example, from Corey Schaefer. You can find the pandas workshop there, only 10 hours, I think. And this is the basic things that you need to learn in Python, actually, before you go to any other programming in Python. So this is import here. It means that you want to import the library, and then we just need to import it. Of course, not all of it will be useful because I delete some of the programming language here. So we ask the Python to import the database. So you can click run cell here. If there's a red color, okay, I'll give you example red color, like this, let's say panda. This is the red color. And then it will say that no module name panda. Why? Because there's no panda libraries. I give you one suggestions if you have problems in what you call this one, in programming in Python. Every time you have problem in Python, you ask your brother. You know who's your brother? ChatGPT. That's what I did most of the time. Whenever my program is not working, I will ask my brother ChatGPT. Right? ChatGPT is our brother because he just born 3 or 2 years back. So we can ask ChatGPT, for example, you can ask ChatGPT, this is my coding, copy paste this coding, and then why my output is this, and then you copy paste this one, and then ChatGPT will tell you, oh yeah, because you are so, no, you will not say you're so stupid, right? It will say you that, of course, because you need to write something like this. Can I open? I think I already simulated one. No, yes. Oh yes, of course. I give you example, right? So let's say this is the one that error, right? Because I put like this, and then there's a warning. So you can ask ChatGPT, for example, hi chatbot, my coding is, but my output, and then you copy paste your output. You copy paste it here. See? So my brother ChatGPT tell me where is wrong. He said, of course, because you have to put pandas, not panda. And then you just copy code back again here, and then you can run it here. So it's smart. I'm not that clever. I just smart, right? I know I have one brother named ChatGPT, so I just ask ChatGPT to run. So anyway, so then this is the model that we need to get the data. If you still remember, we need the data to split it. So the data, we want to take it from the Yahoo Finance, and the data is Bitcoin and Ethereum. How I can get this data? Because you are using the Yahoo Finance. If you go to Yahoo example, Yahoo Finance Bitcoin. Okay, if you go to Yahoo Finance, the code, the ticker here, BTC USD, is actually following the ticker in Yahoo Finance. So let's say you want to do for Malaysia market, yes, you can do it. You just need simply to change the ticker here. Whatever the ticker give by what is name? Yahoo Finance. For example, like the Bitcoin, right? Let me show you. The Bitcoin ticker is BTC USD. You can see here BTC USD. If you want to do for your what you call it, your yeah, what the FYP for Malaysia market, you can do it, but you have to use the ticker from Yahoo Finance. You just need to change it. And then after you got the data, if you still remember, I told you that we need to split the data. We need to train the data. We need to test the data. And this is actually the things that I just told you. So no need for us to do it manually. The machine will do it. And when the machine do it, you can click run, click run, click run, click run actually. And then after we train the data, we test it, and then we evaluate it, and then we'll see the result. And this is the result. As you can see here, this is the predicted Bitcoin. Is the yellow dot yellow orange dot line dot orange line, yeah. So this is the predictions, and this is the Bitcoin, which is we can tell that the predictive model is not that good for LSTM based on the graph. However, we can run the MAPE or RMSE to know whether it is good or not. And as you can see here, the RMSE is 2.1 or 0.14, which is, that's why it's not a good predicted model. Why? Because we need to find a predicted model, if possible, lower than 0 or even close to 0, but 2.1 is too big. This is why this model is not that good. So if you have this data, if you have this language, coding, you can just simply run all, and then it will run for you. If you want to do variable, where is it? Where's the predictive model? The ticker just now. Let me find it. I lost it. Anyway, guys, I think I lost. This one, the ticker. I'm sorry, line 7. In line 7, you just need to change this one, and then you can use it for your FYP as the predictive model. So you only need to change the ticker. For example, not Bitcoin, Ethereum already. What is the company? The problem is I forgot Malaysian company. Let's say Indonesian's company, Bank Rakyat Indonesia, BBRI, right? So you can see this, the symbol in Yahoo Finance is BBRI.jk. So here I have to put it here, the predictive model for, I change it, BBRI.jk. Okay, or Malaysia stock market is KLS. Oh yeah, this one. You see, this is the Malaysia stock market, the head KLSE. So you can change it here also. Head, where's my head? Oh my God, I don't know with this laptop. Oh, this is the head. I found it. KLSE, then you can run it. So yeah, that's actually how we use how we use this machine learning with LSTM, and there are many other models for, oh yeah, this is wrong. This must be KLSE. So yeah, I think that is the introductions of the machine learning in. I have to change everything then. Anyway, this is, if you want to use it, you have to change all the ETS become KLSE. Where is else? The KLSE and so on. And I have so many programming in machine learning neural network, deep learning, volatility with 1 or 2 dV, 1 or 2 IV, you just let me know. I can send to you. All right, I think that's all from my side. I hope it's useful. Thank you very much.
Thank you, thank you, thank you very much, Dr. Rayenda. It's quite interesting. Talking about a simple way of, having this machine learning and how to be incorporated in our research, especially in business economics or even in finance itself, as you shown here the example there. Right. I open up the question. Any question for Dr. Rayenda? This is the time that you can ask him some of the questions that have popped up in your mind, some of the things that he mentioned on econometrics, the basic of econometrics, and the prediction, the forecasting, the forecasting things that the prediction model that you say, or what we compare normally, and what we look at when we do the prediction, right? Question, anyone can open up your mic and then you can ask any of the question relevant to the topic itself, or in general econometrics itself.
Dr. Ray, I have a question.
Siwi.
Okay, for what is so important about the big data analysis? For example, as for economy and finance, we are looking for proxy. For example, KLCI, we are using 30 firms to benchmark for the whole market. So why is so important to look on the individual company and we use it as a big data?
It's okay. That's a good question. Actually, it's back again. This is the one that I told earlier. Back again to your objective. What is your objective? If our objective is we want to know, or we want to have automations every times, for example, every times the stock market changes, and then it will alert us that the aggregate data will change, and then yeah, we can use this. But otherwise, it's not that important. That's one thing. Second one, the big data, theoretically, it will be much more showing you the real informations rather than the, what you call it, the sampling size data. But again, if you watch the video from the Angris, Guiden and Andrews, they keep debating about it. Why? Because big data means we're going to have high or a lot of heterogeneity problem. Then I'll give you an example. How can you say that a person's in Sarawak will have the same behavior with a person's in Perlis, for example? And then how they behave even among Sarawakian also different. So yeah, and then we learn also in statistics, as long as sampling size is represent the populations, then it's already good enough. So until now, it's a big debate about the importance of the big data, but at least big data, until now, they argue that it will show you the real conditions of the company without neglecting some outliers. That's it. So whether it's important or not, then it's back again to our objective. What is our objective? If our objective is only estimates, sampling size data is good enough. But for predictive model, all data is the best data, because if you want to predict something, you cannot throw some of the data. So again, back on your objective. Yes,
All right, that's one of the questions from from Yap. Actually, it's outside from Unimas, but anyhow. All right, so thank you for that. Any other question? Any other concern of any of one of you who want to ask? Actually, this is the time for you to ask, not necessarily just a general topic on the machine learning or big data related, but something that perhaps that you have in mind, that what is it all about of this related topic, especially in econometrics. This is the chance for you to ask. I mean, from one of the experts that already explore a lot in machine learning. Right. Anyone? You can unmute yourself and then you can ask the question. Yes. Next, you want to ask some question actually? Any question, or those of you who feel like you don't feel like to ask live here, you can put it in your in the chat box, some of the question that perhaps that you have in mind. Anyone here? Any representative actually from the economics from the economic course? Any representative to ask the question from service economics, business economics, international economics, and then of course the finance representative. Any one of you want to ask the question related?
Yes, I have question.
Yes, go ahead.
I want ask you the Google Colors. The total is showing example is use Yahoo. If I want to use FB, it's just one chance. What I need to change in the Google Color?
Oh,
Because-
nice, great. Because
because the example is Yahoo. If I don't want use Yahoo, I want use other. How can I change it?
oh, nice. That's a good question. So yeah, that's good questions. This one is only one of the example. Where is it? Let me open. This is the problem. I just close it. Let me give me time. Yeah, generates a price class. Okay, this one. So if you have your data in Excel, it's much better, to be honest with you. So, let me share my screen. Okay, in what you call this one, in Google Colab, when you go here, there's a 3-dot line here. I hope you can see that. And then you can click the folders, right? This folder will have sample data. In this sample data, you can upload your data here. Right, you can upload your data, upload. When you upload it, and then you can upload it, then you can use it as your, what you call it, your data with your Excel. It must better using your Excel, that one, because I thought that you want the easy way. If you already have your data, that's much better. So the data you put in your sample data here, let's say you already upload one data. I don't know whether I have. Okay, where is it, my data? My data. Let me find my data. Is it this one? Yes. I don't know where I put my data. This anyway, you upload it here. Let me find it again one more time. I have the data, supposedly data mentahan. Not test data. Is it test data? Test base 950, test base 950, or this one. So I use this one. Okay. So I put my data here in this folder, the Excel file. And then you can ask the machine learning to read it for you. Sorry, not the machine learning, I'm sorry, the Python, the studio to read it. How to them to read it? Well, this is appear, right? Test B950 XLS. So you click these 3 dots, copy path, and then I just put it here. Then that's it. So this is for your information, this one is my research about price crash risk. There are many research doing price crash risk using the estimation. Even my supervisor in USM, I do not know whether they're using it automatically or they have to count it by manual. But mine, no need. I can ask the machine to calculate first the price crash risk, and this is the result. You can see this is no need for me to do anything because and this is the data looks like. This is the it's my data is actually looks like your panel data, and then I just ask the machine to read it first, and then run the price crash risk, and then after that, as usual, blah 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 blah. Then as I did. So yeah, you can add the data. This is one of this 3 line. Go to the folders, upload it here, then you have to add it. And then you need to ask them to read your data. For example, if your data is Excel, so you have to ask them like this. Yeah, it depends. My point is, yep, it not necessarily have to use Yahoo Finance or other library. If you have your Excel, it's much better. And in fact, that not only Excel, you can also add the pictures. If you still remember that, as I told you about, we can tell from the picture whether this person is handsome or not, beautiful or not. We can do it the same. You put in one folder all the pictures of the attractive persons. Let's say Lisa Blackpink or the BTS gang and so on, and then you put my picture. Maybe my picture will put 0, and then of course the BTS gang will put 1, something like that. They will do it for you. So yeah, not only the Yahoo Finance, not only the Excel, even the image you can add it there, and then you can train them. That's my answer.
Any other question? Any other related question for this very interesting topic about machine learning, especially, or in general of econometric itself? Right. I just wondering. I mean, this is what I always talk about. We talk about machine learning and related, especially, and I always have that in mind even before the pandemic already says that actually the idea behind even the basic econometrics is always a study of econometrics. The basic econometrics is always be the basic of knowing what is machine learning, and beyond that, even the artificial neural network, which have been around for quite a while, and which is part of machine learning. It's just that perhaps when I know artificial neural network, there's about, I think, 20 years back, I've known this name, and now becoming more and more, perhaps because of the data that we have and the richness of the data that we have. Previously, has been the question by Yap just now, and also mentioned by yourself just now, Ray, that what makes different today, the method itself, the machine learning families of machine learning, is that the data that we have, and of what we call today is big data. Rather than we looking into specific sample, we can rather sample them using the whole population. So that's the interesting part. Or perhaps after that we can segregate them, because there's a training and there's a evaluation, and after that you can have your result and whatnot related to that. That's from my understanding of the machine learning. Because I read through, I mean last year I evaluated one PhD thesis which used quite an interesting this SVM method, this one vector model. They're also part of machine learning, that they actually train the data to predict bankruptcy of society, which is very interesting. Bankruptcy model with a lot of variables and so on. And of course, like been argued by the Nobel Prize winner, is that where are we going with this data? Are we going to just doing prediction, or we're doing some regression or estimation. If doing some regression estimation, perhaps there's a lot of econometric issue inside of this data that we have, the richness of the data. Because of the richness, we have heterogeneity, endogeneity, and all those other issues. But of course, we want that richness. They want to but how to control that? I'm sure that machine learning and all those all the related methods inside, they are going into that direction of to know, to understand all those things. And of course, so involve one thing that this is just sharing, not really question, is this topic modeling. I think topic modeling and topic modeling of what you mentioned just of sentiment analysis is rather very interesting analysis or very interesting things to do using Facebook just now. Maybe the question just now about getting the data from Facebook and then do sentiment analysis, or using some topic that have been mentioned a lot in the Google or some way, and then from there you generate the outcome, and then you see how to do that is something that this machine ML here can help us to do such a thing, because we human perhaps we have some limitation of gathering all these things, like how ChatGPT are doing right now, which have a rapid kind of information. I think that's what I have in mind. But this opened up a lot of endless opportunity, especially for research, not just dedicated of economic finance, but a lot more of multidisciplinary, interdisciplinary, because you need this kind of thing with the technological advancement. Now we're getting more and more, getting more easier, like like you just showed yesterday, or the video, and you just showed just now 15 in less than 15 minutes that we don't need Python. You just use some others to estimate Python, which is something new also for me, right? So that's and of course, do you think that this is perhaps, do you think that this machine learning would actually, or this method would actually perhaps one day dominated the econometrics, or something like that?
Yeah, I'm not, how to say, I don't think it will dominate the estimations model, because for me, back again, each problem has their own own way to answer that problem. So have different objective. For example, some research, they just want to know, is it true that, for example, is it true that gold price and cryptocurrency can replace gold price, for example? Then you have to do estimations. But in certain point, you can also make predictive, whether is it true that the cryptocurrency can predict the gold price or the way around. So it depends on what is our objective, and this is, I think like Dr. Jerome or Dr. Ivan, I think you agree with this, that this kind of methods or this kind of questions is appear like maybe since the econometrics itself arise, right? For example, we keep fighting whether, if you still remember, when panel regressions become very famous, people start arguing, is it panel regressions will be much better than time series or better than cross-sectional? And then when there is RCT experiment, people keep telling, is it experiment, it will be the best model rather than the regressions model. And now, of course, we back again, like you said, is it predictive model, machine learning is best than the estimation, like the regressions, or not? So for me, it's back again with the objective. I did a survey actually, and I asked my friend working in companies, not survey a lot of, I think only 4 to 5 people I asked, why they don't want to use machine learning as the predictive model like what Medallion or Renaissance hedge fund did. If you are in finance, I think most of us know Renaissance or the Medallion hedge fund. They're using the algo fund, and for them that there are two reasons. One is this robot trading or machine learning things or algorithms tradings, it's very reluctant with the shock, and market is full of, like you said, heterogeneity. And yeah, and some people will say that this predictive model maybe work for others but not work for for some people also. So yeah, I don't think it's about superiority one against the others, but it's only about what is our objective. And this is related to Siwei, or maybe your statement earlier about the big data. The problem is nowadays, due to the availability of data, company can access to a lot of data. The problem is the company does not know how to treat the data, how to use the data. And then comes the data science people. When the problem with data science people is the company has to find like a PhD holder or maybe experienced people to do this data science, and it's limited and it's very expensive. So then companies start to paying high for these people in data science. When companies start paying high for data science, the university catch this trend, and the university start to see, okay, we find that data science is very, it pays higher, so why don't we put it in our curriculum? The problem is when we want to put in our curriculum, then we need to understand what is data science. In the Faculty of Economy and Business around the world, they see this. If you want to know about data science, then you need to understand about the data analysis. And this is one way. What is the problem? The problem is not many our lecturers understand about programming and how to solve this problem. Then comes another things that, okay, some of the lecturers, they think they found out that Python is easy to understand, then they start to learning about the Python. After they learned about the Python, then they realize that, oh, okay, Python can do many things. One of it is machine learning. So my point is that actually this hype is by coincidence due to this digital economy and big data comes from the company and becomes a hype, but it does not mean that it will be superior than the regression or estimations model. And moreover, I think all of, if you watch, this is very dangerous actually, Dr. Ivan. I think if you still remember, Dr. Ivan, we really hate students that only understand click and click things, right, Doctor? When they open eViews, they open Stata, they open Smart PLS, they open SPSS, they understand click this, click that, and click that. Python can do that also. You just need to have the coding, click this, and you have the result. But the reasoning behind that, the logic behind that is actually econometrics. And many of people out there, they can do the programming, but they don't understand about the, what they call it, about the econometrics thing. So to answer your, not to answer, to further extend your statement, yes, it will be no superiority things about machine learning over the others. That's one thing. And for those especially students in economy and business, my point is learning Python, learning this programming is very easy, but only in Python learning, but also in the econometrics. There are many cases in our class. We have previously, we have two classes, two workshops in Indonesia, how to learn Python. Most of the problem is they do not understand the econometrics, and it really give headache, because how you can teach them, how we can explain about this predicting things if they do not understand what is MSE, MAPE, or something like that, or they not even understand what is regression. So yeah, for those students here, I really encourage you to, my point is in this talk is, I really encourage you to two things. One is you can learn autodidact about the Python later on. Second is please make your this is not because Dr. Ivan class or Dr. Jerome class is econometrics. You can see on all my YouTube video. If they no, we have it. I think yeah. In my my workshop, I keep emphasizing that you don't understand econometrics, you will not understand data science. Python is another story that you can learn. So yeah, this is from my side. Thank you anyway, Dr. Ivan.
Thank you. Thank you very much. Dr. Jerome, do you have anything you want to mention before we close the session?
Yeah, I think yeah, thank you very much for Dr. Ray for the very insightful sharing. But I think the takeaway notes that everyone should I mean emphasize is the basic concept of this econometrics still plays a very important role. Understanding the concept is very important. But also at the same time, as academicians and also the students, it's very important for us to always to learn the new thing. Okay, so since now we're in this big data environment, so it's for I think learning this machine learning is method is very applicable, and at the end, I mean that the output, the result that we have it will become a guideline for us. Okay, so rather than comparing which one is superior than the others, I think it's just a tools for us to get the outcome, the results. So at the end, as a researchers, it's very important for us to have we have the basic concept and we know how to interpret the results and then to see is it applicable or not to the current situations, right? So I think at the end, the important thing is we always need to learn the new things. Okay? So it's now about the machine learning. So I think it's good there for every one of us to to update ourselves, to learn this machine learning method, and then to see whether is it applicable or not in our daily life. Right. So I think thank you very much for Dr. Ring for the very insightful and sharing sessions.
All right.
Back to you, David.
Okay, thank you very much. Again, I think before we close up the session, if there is no last question, no question. We just have to take one. I mean, not one. There's a lot of pages of photos here. So please, those of you who have camera or even your phone, please on your camera for a while. We take nice photo with Dr. Rayenda. This particular today on the 3rd of May 2023. On your camera, please. Just for a while, just for a few seconds, right? Stay for a while there. Even you're in library, anywhere you are, your home, somewhere outside. Right? Let me see. Wow. Page 2, page 3, page 4, page 5. We have 5 pages. On your camera, please. Boys and girls. So far, page 1. Yeah, on camera. Page 2. We have few on the camera. Page 3. All right. I think we just you just maintain or stabilize your face, your smile, or stationary. Make it stationary. Your smile. I will take a picture, or you can take your own picture by yourself. Right. But officially, I'll take mine here. So page 1 first. 1, 2, 3. All right. Let's go for page number 2. 1, 2, 3. Yes. Page number 3. All right. Oh, no one on the camera in page number 3. My page number 3 here. All right. No mind. I'll just take some of the names also. It's pretty important. Page number 4, please. On your camera. And number 5 here, right? 1, 2, 3. Just maintain your smile. Go back to page number 1. So thank you very much for all of you who are attending this particular global classroom today on the 3rd of May 2023. I think we have learned a lot from the Rayenda talk. And then on behalf of the class, the 5 classes actually, 5 different classes. 5 different classes. I'll say thank you very much for spending your time here this morning in the UK. I hope the weather is okay there in the UK. Here in Samarahan now it's raining. I'm not sure in the UK, but usually UK weather will be very unpredictable. Good for machine learning to predict it. And thank you very much. Dr. Rayenda. So see you, Ray. See you when we see you. Jerome, thank you very much, and the rest of the class here. Thank you very much for taking your time here, and happy mid-semester holiday. Because this is week number 7. After this, you have your mid-semester holiday. I'll see all of you, especially in my class, in another 2 weeks' time. Thank you. Goodbye.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Sir.
Bye-bye. Thank you, sir.